Welcome to our presentation on black holes.
What is a black hole? It is an object with such a large density that the escape velocity is greater than the speed of light, hence why they are black. The Schwarzschild radius is the critical radius at which a mass has an escape speed equal to the speed of light. When you compress any object until it is smaller than the Schwarzschild radius, it becomes a black hole. For example, the Earth would become a black hole if it was compressed to a diameter of 0.7 inches. Black holes can be as small as the size of one atom, while being the mass of an entire mountain. Or they could be stellar black holes, which are about 20 solar masses, and the biggest type of black hole is a supermassive black hole. These black holes are more massive than 1 million of our suns. It is believed that there's a supermassive black hole at the center of every large galaxy, the Milky Way included. The one in the middle of the Milky Way is called Sagittarius A star. How is a black hole made? If a stellar corpse is more massive than 3 solar masses, the compression from gravity becomes too large for neutron degeneracy pressure to support it, and it falls in on itself and collapses into a black hole. This is called the Oppenheimer-Volkoff limit for neutron stars, analogous to the Chandrasekhar mass for white dwarfs. If a star starts its life with an initial mass greater than about 18 solar masses, it will leave behind remnants greater than 3 solar masses, therefore creating a black hole. Properties of a black hole. When a very large stellar corpse collapses in on itself, a tremendous mass is compressed into a tiny one-dimensional point, causing gravity and density to become infinite, resulting in infinite curvature of space-time. This point is called a singularity, and this is where our laws of physics completely break down, leaving us with no way to explain with confidence what actually happens inside of a black hole. The only way to know would be to go into one, but doing so would be a death wish, as anything that enters a black hole can't leave the incredible gravitational force. There are many theories as to what would happen to a person if they were to fall into a black hole, like your body being completely ripped apart, reality splitting into two, leaving one of your bodies to be incarcerated while the other falls down the black hole unharmed. The theory of spaghettification, where your body is stretched out due to gravity being much stronger at the point of your body closer to the singularity of the black hole. There are many theories about black holes, but we won't know everything about them until we can find the physics to explain it and then take observations with technology that we don't yet have.
All right, I'm going to be going over the 4 different types of black holes, or rather the 4 different categories of black holes categorized by size, the smallest of which are micro black holes. These are a hypothetical type of black hole, which would have to be at least 22 micrograms in mass, which is called the Planck mass, derived from quantum mechanical equations. And this just gives us a lower bound on the amount of mass we need to form a black hole. And theoretically, these could be made in a particle collider here on Earth, which has understandably raised some concerns, but they should pose no threat if they do form, as they would just immediately evaporate due to Hawking radiation. And up next, we have stellar black holes. These are your good old-fashioned, most common type of black holes. From 5 to 100 solar masses, these are just formed when a star goes supernova and collapses back in on itself, as explained earlier. And in between stellar black holes and supermassive black holes, we have intermediate mass black holes. We've never directly observed one of these, but we have a pretty good idea that they do in fact exist and what they are, based on our indirect observations. These are 100 to 100,000 solar masses, so significantly more than stellar black holes. And we think these form either from stellar black holes that gain a lot of mass from accretion, or a sort of runaway collision of many high-mass stars inside of a stellar cluster. And last but not least, we have supermassive black holes. These are the black holes at the center of galaxies. In the upper right, you'll see the famous picture, the 2019 picture of a black hole. And these are 100,000 to 1 billion solar masses. So this is formed from an enormous amount of gas, like in a galaxy, being compressed in the center, forming a black hole, being fed by the matter in the galaxy falling in. And now we think we may even start categorizing black holes that are larger than supermassive black holes, but for now, these are our 4 main categories of black holes.
Death of a black hole. As you can see in the image on the slide, we have positive particles emitted from the black hole, and this phenomenon is called the Hawking radiation. According to English physicist Stephen Hawking, the black hole's immense gravity pulls the negative antiparticle into the black hole oblivion. This creates a state where the particles and antiparticles are unable to cancel each other out, and it's mainly limited to the event horizon because nothing is able to escape gravitational pull at this point. This process leaves these particles uncancelled and make them real. And then these positive particles are then expelled from the black hole in a phenomenon called the Hawking radiation, as shown in the image on the slide.
So for the future of black hole research, definitely one of the biggest breakthroughs in the past 20 years has been the discovery of gravitational waves. Gravitational waves give us a new way to sort of see celestial objects. We can use gravitational waves in conjunction with on-Earth telescopes to better pinpoint where celestial objects are and potentially photograph and study them. The second thing about future of black hole research is direct observation, which is really exciting. On the right is a picture of an actual black hole taken by the Event Horizon Telescope. And of course, with the future of black holes, there is new physics to be discovered. We don't know how black holes play with things like dark matter, or if there's new particles or new kinds of laws of physics that are happening, most specifically at the singularity at the center of the black hole. So it's definitely a really exciting field.
Thank you once again. Here is our We're Excited, and thanks for taking the time to learn about black holes.